Pencil writes very nicely.
That's good. Okay.
It's nice. Don't probably.
All right. So, simplifying imaginary numbers, right? So let's just remember. So I is equal to what? What is I? What's an imaginary number?
1, -1. Right? It's like, no, sorry.
It's
F negative. It's like the F.
What? It's like 1 and like.
You can do I to the 4th, that's all I remember.
Square root of -1 is I, right? So it's what it takes care of
Why
the.
did I say F?
I have no idea.
Unless my teacher that taught me this, I don't think she knew what she was talking about.
Excuse you, I taught you this last year.
He's out knows it.
No, we started this like right when we were like in quarantine, I think, didn't we?
No.
I think I swore we were doing this.
I think it was like second quarter, man.
It's like 2 months before quarantine.
Yeah.
Y'all supposed to back me up, man.
No, you're the one that's over there talking trash. All right. Anyway, so yes, Zach, there is I to the 4th, right? So like when you have I to the 1st, we're just going to always leave that as I. I squared is equal to -1. I to the 3rd is equal to -I.
Oh, man.
I to the 4th is equal to 1. Good job, Zach.
It goes -1, -1, -1, -1, right?
It goes
No.
I -1.
1, -I, 1.
I'm forgetting the I.
Yeah, you called them all
It
ones.
goes I, -1, -I, 1. And it goes back to I, right?
Yeah, so then for every, like, it repeats after 4. So when you have to, simplify something, like an I that has a higher exponent,
Like out of the 20th.
right, we're just going to divide that by 4.
And you get 5.
Right, so let's do, the example in the
You
book.
get I.
All right, so I to the 16th is the example in the book. So we're going to take 4 divided into 16. So it goes 4 times. So since there's no remainder, right, that's I to the 4th, which is 1.
I don't know how to do long division.
Really? Oh, this is not a good example. This one you're just doing 16 divided by 4.
I don't know what you do.
I divided 16 by 4.
You said long division.
I don't know what I do. Never did it in elementary school.
The elementary school got it English. You were good at math.
I lived in Roanoke City, man. We was lucky to get chocolate milk in the lunchroom.
All right, so then let's do, actually, no.
Chocolate paper paid away.
That was them bad.
So I to the 30th. So that means we're going to take 30 divided by 4. So to do the long division, you have to figure out how many times 4 can go into 30 without going over 30.
They was teaching kids that?
Yes.
Man, he was dumb.
7.
With no calculator.
Yeah, so 4 times 7 is
28.
28. So you then multiply 4 times 7, get 28, then subtract, which leaves you with 2. That 2 becomes your exponent. So that's equal to I squared, which is -1.
That's easy, but I know you're going to throw in some cheese in there later.
I'm really not. That's it. Divided by 4 every time.
So we're done.
Yeah, whatever your remainder is becomes your exponent. I mean, there's more stuff, but like for this part, this is it.
See, there's the cheese.
Cheese is delicious. Don't hate on cheese.
Why are you saying cheese? Cheese slap.
What do you want me to say?
Olives, those are gross.
I was getting ready to say that. The ones, the orange ones, they're not the
Or
orange.
anchovies.
Ooh.
Like the green ones with the red pits. Yeah, those are like just butthole.
All right, so then sometimes you have things like this that we're going to have to simplify. So when you have a negative in the square root, that's just going to come out and become an I, right? So what's the square root of 36?
6.
And then you have an I with it since it's negative.
Right. That's it.
For that one, yes. We'll be done when we're done. Quit saying that's it after everything I say.
Is that it for the whole lecture? I'm saying, is that it for that problem?
Yes, that's it for that problem.
Poor whiteboard.
Zach. All right. So then when you can't simplify your square root any further, so like the square root of -7, so you're just going to put the I outside the square root and make it a +7. To pull out the negative, it turns into an I. Right, and then 32 we can simplify down. Right, so remember when we did this?
I thought I was past this.
No, it never goes away. Right, so we can circle in groups of 2, which means we're going to have 4 outside and an I since it's negative, and then this 2 left inside.
There's the cheese. There's the olives. There's the olive.
All right, we've done this before.
And you say I'm going to go to groups of 2. So we have.
Right, so then, huh? Yeah, so 2 times 2 is 4. I figured you would.
This is the complex number part, right?
This is the imaginary number part.
Which one's the complex number?
The part that's coming later. It's all very simple, but. All right, so we're going to do Ariel's favorite thing, even though she's not here.
Are you recording this?
Yes.
Is it slope?
No. Ariel doesn't like slope.
I thought she liked the slope guy.
No. Quadrations.
Oh, shoot.
Oh! This was multiple.
So we can't factor it.
Oh, gosh.
Don't these take like a whole page to
No.
You sure?
I don't think so. They shouldn't.
They take a page and a half, Steven.
No, they don't. So, we're going to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Oh, yeah, by the way, our days of trig are over. We're officially in pre-calculus.
I like trig. Is that AC?
Yeah.
Good trick.
Wait, is that 4AC?
Yeah.
Is this more like algebra? Oh, let's get into it because this is going to be a lot better for me.
You know,
I hate algebra.
sophomore
This is going to
year-
be a lot better for me.
Sophomore year during soccer season, I got a concussion, and before I could play against Midland Trail, Mr. Patton made me recite that to him.
That makes me really happy, actually.
You should go to yeah, very up to probably remember it.
Probably. All right. So, again, negative b plus or minus the square root of b squared minus 4ac over 2a. So, remember, whatever is in front of x squared is your a. So, in this case, a is 1. Whatever is in front of x is always b. So, that's negative 2. Whatever is at the end without a variable is c.
Is this complex or imaginary that we're doing right now?
I mean, really, we'll get a complex solution to this. If it just has I, it's imaginary. Complex is when you have like an imaginary number added to a real number. And you just kind of like leave them like that.
No. Will it do anything?
Yeah, you can.
You could, but you're more than likely going to plug it in incorrectly and get the wrong answer. And because,
Challenge accepted.
go ahead, you're going to get a domain error. Because, again, this whole section is on complex and imaginary numbers. So that means in this square root here, we're going to get a negative, which the calculator can't do.
So really personal.
So that means we're going to have 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 over 2 times 1. So we're going to get 2 plus or minus the square root of 4 minus 20 over 2. And then we get 2 plus or minus the square root of negative 16 over 2. The square root of negative 16 is 4i. And then you can divide 2 and 4 by 2, so you get 1 plus or minus 2i.
That was real quick.
Do you need me to talk through it again?
Yeah.
Okay. So I just plugged in a, b, and c into my formula. Right? So I have negative b, so I change the sign of b and make it positive 2. Plus or minus b squared, so negative 2 squared, which gives me this positive 4, minus 4 times 1 times 5, which is 20. And then over 2 times 1, which is 2. So then 4 minus 20 gives me this negative 16. And then when you take the square root of negative 16, so that's where the I comes from, and then the square root of 16 is 4. Then I did 2, and you always have to have that plus or minus, so 2 plus or minus 4i over 2. And then I divided 2 by 2 to get 1, and 4 by 2 to get 2.
I thought today was gonna be a bad day. This ain't too bad.
I told you guys it would be a good day.
This is way better than what you guys are doing.
I've mastered that.
What?
Alright, class.
Pastor Bill says that for every audio.
I know, you told me that yesterday.
When he says that, it says, welcome back, gang.
Let's add these complex numbers. So let's say we have 5 plus 3i plus 7 minus 4i. So we're just combining like terms, right? I just put them in parentheses to show that they're two separate complex numbers. But really, it's just... So 5 plus 7 is...
Is this foiling?
This is adding. We are gonna foil, though.
Multiplication is foiling, right?
Right, we are gonna foil.
Oh my god.
I know that. I know this is adding, but like when you multiply it,
Yeah.
it's foiling.
Yes. All right, so 5 plus 7 is
12.
12.
Shut up, boy.
And then 3i minus 4i is
Negative 1i.
negative 1i.
Or you could just put negative I, right?
Right. So that's your answer. 12 minus i.
And does the I always go last?
Yes, the I always goes at the end. All right, so then let's... so this same idea for subtracting. So let's say we wanted to subtract these two. So let's say we had 5 plus 3i minus 7 minus 4i. So we've got to distribute that negative first. So then we would have 5 minus 7, which is negative 2. And then 3i plus 4i is 7i. So that would be the answer for the subtraction. All right, who's ready to multiply?
We've done this before.
We have done this before.
Why is it all in one chapter?
Huh?
We did it all before, but it was all like in separate, like, little things. All in one.
Yeah, so now we're just doing a quick recap.
So tomorrow.
Always the all ones.
Tomorrow's just the homework with it.
The day after tomorrow's the olives.
No, then we're going to graph them, which is...
Oh,
That is a lot.
They're straight lines, guys. It's really easy, I promise.
Last time I grabbed something in this class, I don't even know what I was doing.
I just thought graph.
So let's multiply. So we're going to just use the same number. So 5 plus 3i
Pythagorean theorem test.
times 7 minus 4i. All right, so then we're going to foil. So 5 times 7 is 35. And then 5 times negative 4i is negative 20i. What?
Never mind, don't listen.
Okay.
I'm talking to myself.
Plus 21i, and then minus 12i squared. So then we can combine the two in the middle, which gives us 35 plus I minus 12i squared. Now, what is I squared equal to?
Negative 1.
Negative 1. So we're going to replace that I squared with the negative 1. So then 12 times negative 1, or negative 12 times negative 1 is going to make that a positive 12. And then we're going to add 35 and 12 to get 47 plus I as our final answer.
Now, the hard one.
What?
We're dividing these.
Yes.
Division.
Dividing.
Makes me want to crawl in a hole.
How do you divide?
And bury.
I don't remember how to do that.
All right, I'm going to show you. All right, so the division is basically just more foiling, guys.
Isn't this like
All right, so,
a fraction?
yes.
Like fraction.
Fractions.
Was everybody done with that slide?
You,
All right, so we're going to divide 5 plus 3i and 7 minus 4i. So we don't like square roots in the denominator. I is technically a square root, so we don't like I in the denominator of a fraction, right? Right. So that means we're going to multiply the top and bottom by the conjugate. 7 plus 4i and 7 plus 4i. So again, the conjugate is where you change the middle sign on the bottom. Multiply by that on the top and bottom. So then we're going to FOIL on top, FOIL on the bottom, and go from there. So on top, when we FOIL,
on the top you get 47 plus I.
right, because that's the same as what we just did.
Yep. That's it.
So we're going to take a shortcut there.
Oh, so that's a lot of foiling. Man, killing me, Smalls.
Sorry. Would you rather do log cosines all day again? Oh, that's what I thought. Okay, well, sorry. I love foiling, so no.
Everyone just said yeah.
All right, so 7 times 7 is 49. Everybody's allowed to like different things, Stephen. Be nice. 7 times 4i is 28i minus 28i minus 16i squared. So if you do this correctly, right, these middle two should always cancel out. So then you have 49 minus 16i squared, and I squared is equal to what? -1. So then we get 49 plus 16, which is 65. Wait, Stephen, you're wrong. We changed the sign on top. We can't do that. We made it a plus, not a minus. We're going to get different numbers. So we get 35 plus 20i plus 21i. We're adding those in the middle now.
What do you mean you changed the number?
We changed the sign. So instead of we had before 20, negative 20 plus 21.
Minus 4. Now we,
Huh?
Oh.
What is that? Is that a 25?
Yeah, I don't know what happened there.
So we're going to also have a really long answer.
Not really, because then we get 35 plus 41i squared minus 12. And then 35 minus 12 is 23. Oh, wait, that's not an I squared. I'm sorry. That's just an I. So then we get 23 plus 41i over 65.